Morning. In this session, I would like to demonstrate preparing the ternary diagram and also residue curves, and you will be in a position to identify within the given system whether there are any possible azeotropes. So this kind of analysis can be done by using Aspen simulation. We have three components: ethanol, water, and cyclohexane. So first of all, let me define these components. Having defined these components, try to be careful when you want to represent liquid-liquid equilibrium. You need to be very careful while selecting the method. So in fact, there is a specific method in Aspen to represent liquid-liquid systems with Redlich-Kwong equation of state and Henry's law. So I am selecting this model. Now having selected the model, now you will be in a position to go into this ternary diagram. So first of all, let me plot this ternary diagram. So these are the three components we have, and we are plotting 5 tie lines. If you want, you can increase and also suggest what is the pressure at which you would like to do this analysis. So this is how you will be able to plot the ternary diagram for these three components. In addition to this, in fact, you will be able to do other analysis. Let me press on this residue curves. So continue to Aspen plus residue curves, run analysis. These are going to give you, in fact, please go through literature and see what type of information you will be able to get from plotting this kind of residue curves. Right? I may not be in a position to go into those details in the demonstration. And one more thing that you can see, press residue curves or ternary diagram and let's say find azeotropes. Now I would like to find all the possible binary azeotropes among these three components. Right? Having selected this, now you can say what are the possible azeotropes. Now there are two possible azeotropes that are forming. One is ethanol cyclohexane with this composition, and the other azeotrope is between water and cyclohexane. But remember, some of them may not be, you can also use this analysis. Look at the singular points. So stable nodes, unstable node, and the saddle points. So all this information will really help you to look into the distillation while plotting, while doing this synthesis, distillation synthesis. Now from the residue curves, you will be in a position to identify, for example, you will be able to identify what kind of information you will be able to get by looking at these residue curves. So if you start with a particular composition, the likely composition of the products that you will be able to get. So there is a lot of information available in literature. So Aspen can be used to generate for whatever systems all these required information, but it is for you to make use of this information for designing the distillation columns. So with this, I would like to close down this session.